Hello, this is Gaspar Baye. I'm a doctorate candidate, and today I will clarify the doubt between DeepSeek R1 and OpenAI's O1 model. This came to me because many people have been wondering why are they seeing a lot of hype on the internet, or I would say a lot of reactions from many people from LinkedIn, X now, or formerly Twitter, and even WhatsApp group discussions. And I decided to do a comprehensive deep dive into both of them and differentiate them in terms of model architecture, performance, and even produce a demo showing how the two perform hand in hand, side by side. So without further ado, let's get started. Okay, so today we're gonna talk about the performance of DeepSeek R1 versus OpenAI's O1 in terms of their performance, how they perform in popular benchmark data set, and the technology behind their implementation, the architecture, the way they've been trained, and the efficiency. At the end, we will also have a demo demonstrating the capabilities. So, as an agenda, we will talk about the different things I just mentioned. So we will start with performance and cost benchmarks. So the first thing that many people have been debating on the internet is about the cost, the API cost. So the model from ChatGPT, the O1 series, have been developed and by ChatGPT or OpenAI, its parent company, and the API pricing for that is between $1.50 to $60 per million tokens. While the DeepSeek R1, if you're using the platform, you get at least $0.14 to when it is cache hit, meaning that you have a direct access to the content, and 0.55 dollars per million token. So the controversy here is that OpenAI O1 model is not open source. It's a proprietary software or a proprietary model. However, DeepSeek R1's model is completely open source. The source code, including the model, the weights, and everything, is freely available online. You can download that. So the AI cost training, the model training, this is a tentative comparison from someone, Aaron, who calculated it, and the total calculation and his estimates can be found on the link below. So you can see the Vercel app. You can visit that link and see his estimates. And he estimates that the OPT, GPT-O1 is 15 million, around $15 million, between 10 million and 25 millions, while the DeepSeek version 3 and R1 is around $5 million. So there is a big difference between the two. What really caused the huge reaction from various social media is that this benchmark performance. So the aim here is like a high school maths competition in which has been developed since 1980s till now. It's mostly for testing reasoning capabilities, and it's really effective in that aspect. So we see on this M or AIME benchmark that DeepSeek is leading O1 on that with DeepSeek performing 79.8 and O1 performing 79.2. On code forces, meaning coding and the rest, we have OpenAI O1 outperforming um, DeepSeek R1 with O1 96.6 and R1 96.3. On the graduate uh, Google Proof QA, which is like a form of, it's a benchmark data set that has like graduate level difficult or hard questions uh, where PhDs or people doing their PhDs usually score 65 accuracy and above, while other normal people who are not doing PhDs or others, score 35 or 34. So in this benchmark, uh, OpenAI O1 again outperforms DeepSeek R1. Here in mathematics competition or benchmark, DeepSeek R1 outperforms O1 with DeepSeek R1 having 97.3 and O1 having 96.4. In MMLU, which is a general understanding language understanding benchmark, general knowledge and the rest, again, O1 outperformed R1 with 91.8 for O1 and 90.8 for DeepSeek R1. On software benchmark, we have SWE benchmark, we have 49.2 on DeepSeek and 48.9 on R1, on O1. So DeepSeek is outperforming R1, O1. So on average, OpenAI's O1 outperforms the DeepSeek R1, but in different specific benchmarks like AI ME, math, SWE benchmark, and the rest, DeepSeek R1 outperformed O1. So that caused a lot of reaction on the internet, and people, and even causing causing Nvidia to lose a lot of billions in the range of between 600 around 600 billion dollars, and globally it's around in the order of $1 trillion loss in the stock market. If we go again to technological innovations, what makes DeepSeek R1 and O1 different? So the model architecture of OpenAI O1 is proprietary. They did not explicitly provide all the details about it, but they mostly focus on optimizing reasoning and performance. And then the model architecture for DeepSeek R1 is using mixture of experts. We will come to that in the next slides. I will explain what is mixture of experts. And the training method used by GPT-O1 is supervised fine-tuning with reinforcement learning with human feedback. I will explain that as well. While that for DeepSeek R1 is reinforcement learning with minimal supervised data. So we will start with the model architecture, mixture of expert. What is mixture of expert? It first started in the 1980s or the 1990s at MIT, where it's a collaborative work between MIT and the Department of Computer Science, University of Toronto, where they coined the term adaptive mixture of local experts. In this aspect, they have like sort of multiple different network experts with expertise in different domains within the network, and they use like a gate to weigh the input and then route information or route requests or task to the specific expert that knows that part of input in the network better. So fast forward to 2025 now, we have mixture of experts. This was developed by a group of scientists. And in this scenario, if you need the full blog for this, it's I included the link to the Hugging Face blog, so you can go check it, including the links to the original papers. So please, if you want to go deeper into this, check the blog from Hugging Face. So in this scenario, we have sort of a gating network, and we have multiple experts which with multiple different um, expertise. So we have this gating network that provide like routing tasks to specific experts. Yeah. So the introduction of mixture of expert came with a sparsity of the model. What do I mean by sparsity? I'll explain in the next slide. So sparsity in this context is based off the model density. So in the left side, we have every input connected to every linear, linear middle layer. So that is a fully connected, dense layer. However, we don't need to do that with a sparse layer because every input can just connect to few next hidden layer. Okay, so that makes the density of the layer sparse or not as thick as that for a standard or normal dense layer. So the mixture of expert adopts this sparsity methodology. The technological innovations on supervised fine-tuning, the training method used by OpenAI O1 and that of DeepSeek R1. We will talk about the supervised fine-tuning with reinforcement learning with human feedback. So in step one, we have supervised fine-tuning. And in supervised fine-tuning, it generally means that we guide the model with labeled data on how to, we train the model with labeled data. So we have like sort of a labeled data of things or tasks that we want the model to learn. And then we say, okay, this type of task have this label, this type of task have this label. We train the model with those labeled data and the model understand how to perform in those things, in those tasks. Um, so that is basically what is supervised fine-tuning means. And it's kind of a cheaper technique. So people usually adopt that and they use that to like improve a model for a specific task, meaning that they want a model to be good, maybe in biology. We have labeled data for biology and we train the model. We now improve the model's weight in the knowledge that we want it to understand. And that model will become like a domain expert in biology. So that is a high summary of what is supervised fine-tuning. They went further in step two, where they perform what we call, they collect, first of all, data, comparison data and train a reward model. What do I mean by a reward model here? The reward model here is the reinforcement learning, which usually rewards a model on every time, on every task that it gets correctly. Meaning that you have like some sort of a um, you have an agent that interact with an environment, and you want the agent to have to achieve maximum reward. And every time the agent perform the desired task, you give the agent a reward. When he perform the wrong task, you penalize it. We will go deeper into reinforcement learning in the next slide, but this is just the basic understanding of RL, reinforcement learning. And in this scenario, when the model is doing or performing all of that, it uses what we call the policy. So the policy is just like the optimal model parameters that help the model to perform well or better. So in this case, a human provide feedback to the model to improve, meaning that in every time the model fails or the model need guidance, the human is the one providing feedback in order to for the model to improve. So that is why we call reinforcement learning with human feedback, because the human is the one providing feedback to help to guide the agent in a better action. So um, in contrast to what DeepSeek R1 use, DeepSeek R1 uses pure reinforcement learning. And when I say pure reinforcement learning here is that we don't have a human to provide feedback for the reinforcement learning agent to improve. In this case, the agent here interact with the environment via observation, and those observations are usually denoted as the states, and the agent perform actions to the environment, meaning for every observation, it perform an action, which we call the observations are the states. It perform actions, and based on whether the action was good or bad, it receives a reward or a penalty. So the objective of this agent is that it has to maximize its cumulative reward, meaning in the long run, it wants to maximize the cumulative reward. So in this state, we just throw an agent in an environment and we let the agent to learn or figure out things by its own. This is similar kind of to what um, to what babies learn, right? When a baby, for example, a baby doesn't know what is fire, right? When the baby touches the fire will burn the baby, and the baby learns that, hey, if I touch this thing again, it will burn me. Next time, it will store it in the memory, and next time the baby will avoid touching that fire. So that is an example of a like that learning by actions, reinforcement learning. So that is how DeepSeek R1 trained its model to figure out things by itself. So that is the main or core concepts behind reinforcement learning. Okay, how about the efficiency and resource utilization? So generally speaking, um, OpenAI, we all know, had high operational cost because of the resource requirements that they had. And R1 had kind of a good performance from what we saw, from what they reported in their results, at a fraction of the cost. Using like we all know about the sanctions they had, and we don't know if they had you know, if they had more GPUs than what they reported, or if that cost was we don't know we don't know all the details about the cost. But what we know is that they reported that they kind of developed DeepSeek R1 using a significantly smaller cost compared to O1. And that is one of the other aspects that caused a crash in the stock market. All right. We are done with the technological improvement, efficiency, and performance. Now let's get our hands dirty. Let's go to the demo. I'll demonstrate how we can locally have O1, not O1, R1 on our local machine. Since it's open source, we just need few commands to achieve that, and we can have it offline, completely offline on our machine. However, GPT-O1 is paid, so we don't you need to subscribe and pay a subscription fee to have access to the. Hello, for demo resources for GPT-O1, which is you just visit chatgpt.com and you buy a subscription, and you will able to you need to get a pro account, and you'll be able to have access to the O1. While the DeepSeek R1 is completely open source. So we use the Ollama tool, and then the DeepSeek weight or model, we download it using Ollama, and we just run it. It's as simple as two commands. So we will test them in two tasks. One is on math, and we will see how they reason without any explicit instruction about reasoning. And the second one is on word counting. We will try to see. This is a very popular question that they've been asking models online. So I wanted to see how these two differentiate in distinguishing how many R's exist in the word strawberry. And I want to see how they reason. Um, okay, let's go to the demo. Let's start with mm, DeepSeek. Okay, so for you to have access to DeepSeek, you need to download Olama. And to download Olama, you can use uh the let me show you the website on where you can download Olama and different aspects. You can visit Olama. It's also open source and it has a lot of stars, 117K. And once you go there, if you are using Linux, you just run this command. That's it. If you are running Windows or Mac, you can just download the exe or the zip file from Mac and install it on your machine. And these are all the models that you can run on your machine. It's more than that. You can explore in Olama. I think they have a website here. Yeah, olama.com here. And you can actually you can download any model that you want. You see, this is DeepSeek R1, and you can click on models. Let me zoom this. You can click on models, and then you can have all the models that you want. And you can see, based off the downloads, DeepSeek R1 just 10 days updated 5.6 millions, while Llama 3.3 is 1 million, and then fee from Microsoft is 250K, and so on and so forth. Llama 3.2 is 7.9 million, Llama 3.1 is 21 million, and so on. So you can actually download any model here with just a simple command that they provided here. You just say, Olama run that model name. That's it. And that being said, let's go back to our terminal. I already installed using the curl command. And for you to check what are the different models that you have, you can do Olama help to find out how to use Olama. Okay. You can find out how to use Olama. You can serve. You can even run a local server locally on your machine, and then you can serve via API. We will use Olama list. You can also copy if you want. You can remove a model if you want. You can show the details of the model if you want. You can stop a model. You can pull it from the repository. It's just like containerization in like Docker, but this one is using AI models. So let me do Olama list to show what are the different models that we have. Let me just zoom out a little bit to see. So we have Quen, we have Llama 2, but our objective is DeepSeek R1. So then we copy DeepSeek R1 and it's 8 billion parameter. We also have the different other models that exist. Okay. So to run it, we just say Olama run and then the model name. And this will initialize a prompt for us to interact with the AI. On the other side, I install what we call NV iTop, which is a tool to monitor the GPU utilization for a model. Right now, the GPU utilization is 0% and the memory is 64%. But once we fire up this DeepSeek, we will realize that the GPU utilization will become red, meaning it is consuming the content. So let me copy the first task from our demo and then paste here. So what is the square root of 16? I did not ask how you reason. I did not ask anything. I just asked what's the square root of 16. Let me put a question mark here. So let's see how it's reasoned. So it starts with think. And then it says, let me scroll up first to show. It starts with think, and then it says, I find the square root of root 16. I need to determine which number multiplied by itself equals 16, which is a good, a good way of thinking. I recall that squaring a number means multiplying it by itself. So if the square root x squared is equal to 16, then x must be the number whose square is 16. Testing 4. 4 times 4 is equal to 16. This satisfies the equation. Similarly, negative 4 also squares to 16 because a negative number is, times a negative is positive. So both 4 and negative 4 are the solution. However, by convention, the principal square root of 16 is 4. Think, to find the square root of 16, we need to determine the number multiplied by itself equals 16. So this is usually how a human reasons, right? This is usually how a human reasons, and that makes DeepSeek really, really, innovative in that aspect. So let me rerun it again, and we check the GPU utilization, okay? Because we did not check it this time around. Let me first quit this, and okay, now it's running. You see, GPU utilization is going really high, so it's green now, meaning it has terminated doing the thing. So that is how you can run any language model locally. Okay, you can use Olama, you can use Olama to do that. So now let's go to GPT. Let's go to GPT-4 and test how it reacts or how it performs with the same question. So I paste the same question here for O1. I paste the same question for O1. I remove that and put the question mark, and then we run and see. Let's see what it's, so it's reasoning, and it gives us the number 16 has two square roots, plus 4 and minus 4. However, when someone asks the square root of a positive number without further context, they are usually referring to the principal non-negative root in the case. So yeah, that's correct. However, we don't see the reasoning process. We know it went through a reasoning process, but we were not shown how it reasoned out step by step and how it came out. It came to the number 4, plus 4, minus 4, and then 4. So, but both of them were indeed correct. The next phase is the second aspect of the R's from the word strawberry. So let's go back again to GPT-01 and ask this question. Show me your reasoning. So let's run this and see what it says. So it's performing reasoning here. And so breaking down the sequence, I'm counting the letters in strawberry to find R's, sorted by position, S1, T2, R3, and A4, W, and so on and so forth. So they had like an index to count it. Notably, there are 3 R's. Unraveling the sequence, I'm working through identifying each letter in strawberry to pinpoint the R occurrences. The word include 3 R's. So indeed, it successfully found the number of R's in strawberry. Some models actually failed. I think earlier versions of GPT itself may have GPT-4 or something have shown like issues with that. But I think they improved lately, and we can clearly see it is really doing great. Let's go back to our DeepSeek R1. So if I paste the same question here and run it, it thinks and says, okay, let's go and see how it is determining that. So we asked how many R's are in the word strawberry. Show me your reasoning. All right, let's tackle this question step by step. The task is to determine how many R's are present in the word strawberry. First, I'll write out the word strawberry. The way that this is thinking is similar to human thought process. If I was the one, I will definitely do the same. I'll first go write it on the board or a whiteboard, and then I try to start, examine the letters and then start counting, and then that's how I approach it. So, which kind of really it's exciting to see this technological innovation in that space. So once it reaches an R, it says this is our first R. It count one. And then when it goes to the second one, it says count two and count three. So indeed, it found the right answer, which is there are three R's in the word strawberry. So generally speaking, both models are actually doing great. And I would say uh, overall, OpenAI is doing better because of the if we sum all the average and then we find we sum all of it and find the average, OpenAI O1 is better. But the controversy or the huge reaction that we observed on the internet is because of the fact that R1 was beating O1 on certain benchmark. So people were like, talking about it a lot on the internet, on social media, or even on LinkedIn and Twitter, or now X. Okay, so if you like the content, please subscribe to make sure you always, have fresh content from me. And if you want to provide any, feedback or information about what you just learned, provide your comment below. And if you need similar contents or you need something else, please give me some feedbacks in the comments so that I will know what to provide next time. And that being said, I wish you a wonderful and enjoyable day. Thank you.